Hey, here we go. All right, I'm Ryan McPeck. I lead smart accounts at MetaMask, and today I'm going to be talking about our delegation framework and permissions and privacy and what's possible and whatnot. So I'm going to walk through kind of like the current state of wallet, what's going on with wallets and users and dApps and all that kind of stuff real quick. Then I'm going to go into our permission system, which is delegation framework. I'm going to then talk about how we used it in the past, maybe a little bit how we're currently using it, and then into what's possible with privacy. And it's gonna be amazing. Yeah. So where we're at right now is like all these problems with password, seed phrase, all this kind of stuff, and users, and if they want to export account, they got to take their private key or their SRP and bring it to another wallet or whatever the case might be. And it's not that flexible. It's not that portable. It can be portable, but not really done right, right? Like it's not very that secure. Uh, so what we have is delegations through our delegation framework, which are permissions. You can share controlled and scoped authority with other accounts, and you can customize it, and they can do certain things. So how we're doing that is delegation framework. You can see here some friendly animals that are working together. That's pretty cool, right? Uh, and so we've been working hard on this stuff for over 2 years. And what it is the most powerful EVM permission system that unlocks authority abstraction through a set of Solidity contracts. And what it does is through delegations and all this stuff is it allows you to share fine-grained permissions with anything, another account, an agent, a key, whatever it might be. And so how it does this is through this struct here. You have a delegator, who is the address who's sharing the permission. You then have the delegate, who you're giving that permission to. And then what you can also do here is tap into these caveat enforcers. Now, these caveat enforcers are the guardrails of the delegation. They're just contracts, so it's completely extensible. So you could make a caveat enforcer that will make sure the person you're sharing permission to can only withdraw 100 tokens from your account. You could make sure that it can only call this specific function. It might be a vote function. You can take it a step further and make sure this caveat enforcer can deploy a contract for you. It could make sure a contract's deployed, right? And we're going to go into a whole bunch of different things that you can do with caveat enforcers, but it's completely extensible and it's very powerful. And the main workload that comes into the delegation framework is this delegation manager. It must implement 7710, which is our standard for interoperable accounts via delegations. It allows you to redeem delegations. And so what this does is when I share a permission, a delegation with another account, that account would then call the delegation manager and pass in the permission, the authority they're acting on behalf of, which is my account, and then the action that they want to do. And so I would share a permission with my friend saying, hey, you can withdraw 100 tokens from my account. And then they would say, okay, I'm going to transfer 100 tokens to this address. And they would pass in their authority and that execution. It would go through the delegation manager. It would pass through all the caveat enforcers, make sure everything is good, and then execute that action. And you'll see that right here. Me as the delegator I'll give you a permission to send those 100 tokens. I'll give it an assigned message, which is off chain. It's just 712 signed message, so it's completely gasless. That delegate or redeemer will then call the delegation manager via 7710 interface, saying, hey, this is exactly what I want to do. When we get into the delegation manager, that's where it does the magic, like I was talking about. And before the execution, it calls these hooks. There's a before all hook, before hook. So that's when we can test the execution against the caveat enforcers and say, hey, this is what the redeemer's trying to do. Is it within the guardrails of what the caveat enforcers on this authority allow, right? And if so, if everything's good, then we call this special function execute from executor on the delegator account, which is the only requirement for a root delegator. So to be able to give a delegation using Delegation Framework, you have to have this execute from executor function, and it has to be permissioned. So only the delegation manager singleton contract can call that function. If you have that, you unlock the magic of Delegation Framework, and you're supercharged by delegations. We will then call the execution that the redeemer wants to call from the delegator contract. So it'll call that ERC20 contract transfer on that contract. The transfer function will see the message sender as the root delegator, so it's allowed to happen. It does the transfer, right? It executes that execution. And then we come back to the delegation manager and we call the after hook and then the after all hook. What's really cool about that is we have pre and post execution hooks. So we can do really cool things with the caveat enforcers, right? Like I said, in the pre-hooks, the before hooks, you can check, hey, this guy's trying to transfer 100 tokens. Like, that's cool and all. But in the after hook, you could also check what does the user get in return, right? So you could make a delegation that says, hey, here's 100 tokens if and only if I receive 1,000 of these other tokens in return, right? And it all happens atomically. So if the user doesn't get those 1,000 tokens, then it's all going to revert, and the user won't lose their 100 tokens or whatnot. So at that point, with these before and after hooks, you now have intent-based permissions. You can create these intents that say, hey, you could do this if and only this, right? And you can also flip that upside down, right? You can say with delegations, it's unlike session keys in the way that we're not giving you a key to execute something on my account and you have to submit it via my account. We're sharing a permission with your account, meaning your account can execute a permission on my behalf, right? So in doing so, we can actually flip that in return and go, I'll allow you to execute exactly this execution. And if you do that, I'll share these tokens with you. I'll send you $5, 5 USDC or something like that. And at that point, you have gas abstraction, right? You can give this permission to another account to perform this exact execution on your behalf. If they do, then you'll reward them, right? So you have these permissions can get as fine grained as you want, and they can do really cool things. Okay, yeah, delegation toolkit, right? So that's our SDK. It's a yeah, what did I say? Handy dandy SDK, right? So this allows you to work with Delegation Framework, create delegations really easily. You can send delegations, redeem them, and it also works with our 7715 permission system, which is coming out in a couple months. It's already released on Flask, and you can start playing with it. What that is it allows dApps to request permission from the wallet. So a dApp can say, hey, I don't care who you are, but give me 1 ETH, and it can show it why it needs that and everything. The user can then gaslessly share 1 ETH with the dApp, and it can add rules to it, right? It can say, here's 1 ETH. Again, if and only if I receive this NFT, this specific NFT in return, and now you have a safer interaction for users where users can be more empowered. So yeah, you guys can start playing around with the Delegation Toolkit SDK. Oh, so here's a real use case we have. So last year at ECC, we came out with a red balloon game, which was really cool. What it was a DApp. It's an embedded Gator app that uses a burner private key. There's no wallet connection. There's no create an account. There's no seed phrase. There's nothing. You go to the app and boom, you can start using it. What happened was there's these 10 balloons and you got to go around the city and ECC, and it was in Brussels last year, right? And you got to find these 10 red balloons. Once you find 10 red balloons, you win 5 ETH. The problem is it was impossible for one person to find all 10. So you had to coordinate and you had to share, and it was more of a social experiment. Uh, so when you have a red balloon, you find one, you could share that with someone else and ask for a commission. So here's my red balloon number one. You can use it if you're going to win. Then I want to have 15% of the commission off that 5 ETH that you win, and we can do that using our intent-based delegation framework. So yeah, that was really cool, and we had a really good, really fun winner. Uh, yeah. Oh, and this is all open source. So if you want to run this game again, you can just fork our repo. It's on Red Balloon. It's like under MetaMask GitHub, and you can fork it and spin up your own game. Let me know if you do so. That'd be really cool. Okay, so we got this guy who always wants to find out what I got going on in the blockchain. Uh, and so we're going to dive into kind of like how we can make these delegations a little bit more private. And one of the ways we can do that is with ZKPs. So here's one for let's think about account recovery, right? One of the thing about the delegation framework is the caveat enforcers, they have this args value that allows the redeemer to pass in specific things when they're redeeming the permission. So they could pass in a ZKP into the caveat enforcer. So one thing we could do is the user could say, hey, this email address can recover my account, right? And it could be a ZKP email address. So what happens is this email address can recover my account, and then their friend, or maybe it's their email address or whatnot, they prove that they have this email address, and then they can inject it into the transaction. No one knows what the actual email address is, but they privately prove that they have this email address, and now that person with the email address can recover this user's account, essentially, or act on their behalf, right? And we can do that through delegation framework. There's another cool way using ZKP, ZKTLS is like our last hackathon winner, TechSwap. They did something really cool where they built a dApp that requests permission from the wallet, saying, hey, give me some ETH and I'll trade it on your behalf. I'll trade it on your behalf if and only if you make a tweet saying you want to swap these tokens. We'll wrap that up into a ZKTLS and inject it into the permission at runtime. And that's the only way it would execute a valid swap. So that was pretty cool as well. Okay, yeah, here we go. So one thing about delegation framework is like, blockchain and transparency. It's great and all, not very great with privacy, but let's say you have a delegation, it's off chain, so no one knows about this delegation when it's signed and created. You give that to whatever you give that to, and it's still private. No one can see it. It's off chain. Everything's good. But when they actually want to execute on that permission, they need to put that on chain. And so once they put that on chain, once they execute that permission once and actually execute that transaction, then it's on chain. Everyone can see it, right? Which is probably fine for most cases, right? But let's think about like I don't know, let's think about a limit order. Let's just think, or a multiple recurring limit order, a recurring swap, or something like that, right? If you have that and you do it first, that's fine. It'll get executed when it's executed and everything's good. But once it's on chain, people will be able to see that strategy, right? And whatever that strategy is. So that's where FHE can come into play. We can abstract away the whole caveat enforcer, all the logic in the caveat enforcer, and encrypt it through FHE. And so that's you can think like, what if you had a very complex trading strategy? You don't want anyone and everyone to see that, right? So what if it's like, hey, here's a whole portfolio rebalancing strategy through delegation framework? You can do that. You probably wouldn't want to do it without FHE though. And this kind of just it extracts all that out and uses encryption to rechange and completely change those caveat enforcers. So I'd be really excited to see how that works. So yeah, this kind of just lays out with our little stick figures again. Blue Man makes this confidential trading strategy using FHE caveat enforcers for the delegation framework. Orange dude says, "Yep, I want to execute on this because they know how it works, what the actual trading strategy is." They execute this, and Orange dude could be like a DApp, like a portfolio DApp, or automated strategy, some trading, advanced trading protocol or whatnot, and they can execute that on that, and it's completely encrypted. Yeah, so that would be really cool. Someone should definitely build that. Let me know if you want to do that. Okay. Yeah, here's some key takeaways you can read, and ultimately, delegation framework, it's super powerful. You can do a whole bunch of stuff. The caveat enforcers are just external contracts. You can make your own contract. Delegation framework's completely open source. You can fork it. You can build with us. You can do whatever you want. Uh, and you can do really complex things. And I think it kind of sets the tone for a possibility of privacy, like we kind of talked about. And I think we're just getting started. Like the privacy is kind of just being broached, and I think we can take it a step further and do some really cool stuff. So yeah, there's my Twitter or X, and you guys can reach out to me, talk to me after. Let me know if you have questions or want to talk about it. Uh, Thank you so much.